So what we're going to do is we're going to kick it off with a short introduction, and then I'm going to pass the mic over to Kisan and Peter Shoup, who are going to give us an introductory lesson to point clouds. Again, this is a very introductory level webinar, so the purpose of this presentation today is really to give you an understanding of what point clouds are to your design workflow and how they can definitely improve, site measurements and to speed up your day-to-day design production work. But there are other applications that we can use point clouds during design and production, even after construction is completed. So we'll take a look at a couple of use cases. Peter and Kisan have a ton of experience of using the hardware for collecting data to create the point clouds. We'll look at a couple of options on the market for using the hardware and software. And the idea again is just an introductory to generate some curiosity and questions later on. If you have any questions, we're going to leave some time at the end, so please post them in the GoToWebinar question dialog, and we'll go from there. Okay. So quick introduction about SolidCAD. We always want to start with giving you an idea of who you're working with. We have quite an extensive timeline, dating back over 25 years and even further back. But we can only fit so many decades here on this timeline. But over the last few years, we've been under the Cancel group of companies, and it's been a great relationship working under Cancel. They are a much bigger company, and we're the big primary business unit handling the Autodesk business and all the complementary solutions to the Autodesk workflows. SolidCAD looks after a number of different industries, and we have specialized teams within our company who look after these particular segments in the market. So, depending on where you are and what you do, you might have either one salesperson or technical lead that you work with, or you might have two if you're, multidisciplinary. So, it's great working with SolidCAD because we do use our staff and we help, grow them into being specialized subject matter experts. The one thing we really, pride ourselves on is really understanding your core business and understanding why you do and how you do it, and finding out where we can help you leverage new technology and improve that overall workflows. So we don't just like pushing a product or solution unless we really understand your core business. As I mentioned, we are a group under the Cancel umbrella, and there are a number of other companies within our family, we can call it. And we work hand in hand, and there's sometimes we do some coordination and collaboration with our other sister companies within the Cancel group of companies. So it's a good chance that you might be working with Cancel or Building Point for other products like Trimble, or even acquiring your paper and plotting equipment from the Cobalt group. Some of the other partner products that we support beyond just our primary Autodesk business, but we have also solutions for visualization, for management of data, for measuring on site with our scan to BIM technology. And then we have some of the cloud offerings for dealing with some of your data for site reviews or design collaboration. So a lot of different tools that we have in our portfolio, and we can help you really, integrate those products together. The services we offer, are even greater by, offering you just our day-to-day stuff for, BIM training, just onboarding new staff coming online in your company, helping you implement new technology or workflows. We also provide, customization and scripting work for a lot of our clients. We have a dedicated group of staff, around, I believe, 6 people in SolidCAD who all they do is just do programming and API work. And they're doing it on the Autodesk platform, on Forge, on the backend cloud, on a number of other tools, helping clients bridge their design tools. One of our big portfolios in our business that keeps growing is our BIM 360 cloud service, which is the cloud service for all the Autodesk products. And right now with the COVID-19 situation, everyone has to work remotely. So there is an extended trial period right now to help clients take advantage of the BIM 360 services. So you can take your Revit models or your AutoCAD drawings have the information uploaded into the cloud and really start leveraging that to be able to work and have flexible, use from anywhere. This really reduces the amount of overhead for IT by not having to worry about VPNing, remote desktop, setting up dedicated servers just so people can access it from outside of their office. And the great thing about BIM 360 is also far more secure than traditional IT setups. If you are looking for training, right now, obviously our offices are closed for the time being, but we are offering a ton of online training sessions, and they have been a tremendous success. We've actually maxed out a lot of our online training sessions, for BIM 360, for Autodesk Dynamo, for Plant 3D, a lot of different offerings. So head out to our SolidCAD website, take a look under the training subpage, and take a look at what our schedule is looking like. These are live trainings. We are offering, dedicated workstations online that you can use. So definitely, this is a great opportunity to sharpen your skills with our software. So I'm just going to skip through these. If you're wondering what we look like, well, there's Peter Shute there in our technical team, and myself here and on the Ontario team, right there, second under Michael Rutolo, and then Kisan is in our Quebec team. So right there between Kisan, Peter, and I, we are working from north of Toronto, Hamilton, which is just west of Toronto, and Montreal. So we've got a really great collaboration going on here with our SolidCAD team and members. But again, we're actually very well connected beyond just ourselves, but with the community and associations across Canada. So we do a lot of support to the local groups and user groups with the software. So if you have an interest in having SolidCAD involved with one of your industry groups, please don't hesitate to reach out to us, and we'll be happy to discuss some opportunities with you. And we're going to just wrap this up, that if you are looking for, further sharpening your workflows and kind of understanding how to map out all the different tools and how all the information is carried through, please get in touch with us, and we'll be happy to provide you with a process assessment. And these business process assessments really help clients understand where the ROI is, especially when you're looking at point clouds. How are you going to use the point clouds in general, and how are you going to really, see the return on that and costly investment? Because it could save you time, but a lot of people have a hard time understanding where the dollar figure is on that hour, or it might save you a critical quality control issue later on. So definitely we can help you understand, the cost savings and take advantage of those type of technologies. And finally, remote solutions. If you are looking for ways to improve your deployments in your virtual workstations, we have solutions to help you really understand how to take advantage of cloud computers to do a lot of the day-to-day management of your design software. So we can definitely take advantage of AWS workstations and show you how to do that. We offer that as a consulting service, but we also have our own sandbox of workstations available for rent. And again, these are great because you can use virtually any computer, doesn't matter what kind of computer, and just launch a small little application that could be driving a virtual workstation that has the power to manage big data from either AutoCAD, Revit, Inventor, doesn't matter. It can handle pretty much anything. Anyway, that is a quick introduction to SolidCAD. I'm going to pass it off to Kisan and Peter Shute, who are going to take us through an introductory to point clouds. We're kind of going to move through this in a kind of a good pace, but we'll leave all the questions to the end. So please post your questions in the GoToWebinar, and we'll do our best to answer them at the end or maybe throughout the presentation. Kisan or Peter, who am I making presenter first?
Peter.
I think Peter.
Peter. Mr. Peter, here we are. You are on the stand. Go.
Okay. Good afternoon, everyone. I'm going to set up make sure I have my right monitor going here. Yeah, that looks good. So does everybody see the introduction to point clouds with my glamour shot there? I'm going to assume yes. So a little introduction, I guess, to myself. My name is Peter Shute. I've been with SolidCAD for about almost 6 years now, I guess, over 5.5 years, mainly doing training in Revit, Revit architecture, Revit structure, basically anything architecture related. My background, I have about 25 years experience in the architecture and engineering field working with construction documentation. So I was kind of passionate about everything 3D when I first started with SolidCAD, and I'd always kind of been looking at different technologies, and I really kind of jumped into the point clouds and scanning in general. So let's jump right in, and we'll talk about what point clouds are, and we'll give a little introduction, and then maybe get in a little deeper, and we'll show you what we've been doing and what we can do, and maybe what you can do as well. Okay, so let's jump right in here. So what are point clouds? They're essentially data sets that represent objects in space. These points have coordinates that locate them from a common point and from each other. So if you think of X, Y, Z coordinates, if anybody's familiar with CNC machines, or even back in the old days when I used a lot of 3D in AutoCAD, and we'd look at this, the right hand rule. You know, you can X, Y, and Z if you turned your right hand up and pointed in a Y. And that's exactly what point clouds are. They're points, and each individual point has an X, Y, Z coordinate that describes an object that is scanned in a manner. So how are they generated or captured? We're going to look at 3 different types, or 3 scanners in general, 2 different types really. They're the structured light scanner, like the Matterport, and then also the LiDAR, which is the light detection and ranging scanners. So, you know, the kind of the middle of the road BLK, and then the higher end Faro Focus. So as you notice along the arrow, along the bottom as well, is increased accuracy features and also price when we look at going from, say, a Matterport at one end of the spectrum to the Faro Focus on the other end. So all of these scanners are tripod based. We could actually have one. We do have drones as well, but we're going to talk mainly about the terrestrial ones now. And so they capture data by rotating 360 degrees, capturing the location of objects that are within their range. So what happens is essentially we're moving the tripod-based scanners, taking overlapping scans, which then get registered together to create an overall point cloud. So the number of scans that you take would be scanner dependent, and also dependent on a number of other factors. So let's look at, we'll look at Matterport to begin with. It is a focused light scanner, which means it projects a UV light grid on faces to get the geometry, so to get the location. Still XYZ, still can be changed to a point cloud, but it uses UV light. So it's a little challenging with exterior conditions, but it is extremely fast. It automatically registers with an iPad, and once you're done your project, you would then upload that information of all your multiple scan locations into the Matterport website, and they would create an area in there called your spaces. So that would be your individual projects. So one of the really nice things about the Matterport is the speed. So it's about 30 seconds to scan. And then once you're completed and they've had a chance to kind of work on your project, you have access to the point cloud data. You also get access to a virtual walkthrough, and then also an automatically generated PDF floor plan. So as far as moving on to the laser technology, I just wanted to touch on a few things. Laser scanners use a laser to measure the distance to the object and are extremely accurate. So the laser basically spins vertically and horizontally to capture all the points around the scanner. Once a location is captured, the laser is physically moved to another location and another scan is taken. So laser scanners and focus light scanners like the Matterport are similar in that respect. They are line of sight, so they don't see through walls. So if you need to capture something something that has a lot of little rooms, then you're going to have to take a lot more scans. So depending on the complexity of the project, you may have hundreds or thousands of scans, and it may take several minutes per scan, depending on which method or which technology you use. So the Leica, it is a laser scanner. It's very portable. It's kind of medium distance, medium accuracy. The nice thing about it is it does have apps that you can use and collect or start the scanning based on an app on your iPad or your phone for that matter. It also works with the Matterport Capture app, which is really interesting because, as I mentioned earlier, the Matterport, when it scans and creates point clouds, you cannot do that, or it's very difficult to do that outside because it uses the UV light. So what we can do is we can team up the Leica with the Matterport. So the Matterport, you could do an interior scan extremely quickly and then add the exterior scans to get that point cloud data with the Leica in the same capture app. So it also has auto registration as well. So it's kind of a really good middle of the road kind of solution. So then we look at our higher end or the higher end laser scanner, the Faro Focus. It can capture up to 900,000 points a second. So as that laser spins around and it punches out 900,000 points or creates that point cloud. So that in turn gives a real extreme level of accuracy. And also it has a really far range. So we can scan up to 100 meters. It has a built-in memory card. So this is also kind of a fundamental way that the Faro Focus works. It has a built-in memory card where it stores each individual scan. And it could take minutes per scan. It could take 15, could be 20, could be 30 minutes, but you can adjust it if you only need a certain amount of data, or if it's a small room, you can get it right down to say 2 minutes if you don't need color and you just need a quick scan of the area. So once we get the point clouds from this technology or from these specific pieces of equipment, what can we do with them? So construction phase scanning is something that's really starting to become popular now. It's a very good way to document what is happening on the site and when. So it enables precise construction planning on the basis of the actual data. You can monitor what's going on site, quickly do comparisons for building inspections, and then also keep track of construction progress for legal and technical documentation or as-builts. And also, greater legal certainty for developers, planners, and contractors. You can also share this information with everybody once you create the point cloud. So if you say, okay, I'm going to go to site every week and I'm going to take a scan, and then we're always going to have that information to go back to or to forward it on to all the stakeholders to say, okay, yeah, well, this is what happened at this day, this is what happened at that day. If there's ever an issue, go back to that day, say, oh, look at that, there was the issue, and we can see what happened at that time. Maybe, before you put the board on or before you poured the slabs. or maybe even before you have to core drill somewhere to make sure you're not going to hit a conduit. So what else can we do with them? Retrofit projects. So a very cost-effective way of measuring and quickly preparing plans. The data is extremely precise. Think of a mechanical space, or what the surveyors might call a spaghetti factory, oil and gas plants where there's just pipes everywhere. I don't know how you would go out there with a tape measure and a clipboard and try and get that information. Again, around this idea of just creating up-to-date, accurate information without having to measure. 3D documentation, obviously taking this information out putting it into any of your current CAD software and being able to use that point cloud. Another thing we can do with it is assess the design versus what was built. You know, scan at the end of the project, see how it relates to the original design intent, make necessary changes to create your as-built conditions, and then deliver it to the owner as your as-built. Then we can also take a look at facilities management. So even if there's no construction going on, the client just wants to, hey, we want to have an assessment of what we currently have to then use as we manage our facilities or our physical buildings going forward. So we can scan at any time and pass that along to the owners and operators for continued management. Okay, what else can we use point clouds for? We can use them as a visual reference for creation of a BIM model. So I already alluded to the fact that we can use that as a snapshot in time. But one of the big things that we do is use it more of like a scan to BIM, and I'll talk a little bit about that later and show you a little bit of a workflow of how we use it. But we can use the point cloud as a reference, and that's really all it is. It's maybe on another monitor that we look at it and say, oh, well, that's where this was, that's where this was. So there's a couple different ways between using the Matterport, for instance. So if I'll just click on this link here and I'll show you quickly what the Matterport interface looks like. So the Matterport gives you a complete registered point cloud. All the scans are create this three-dimensional model, and it's actually faces. And then what we can do is click inside and assess or go around to every scan location and take a look at any detail, anything in these 360-degree views that the Matterport camera captures. Okay, so this is one of the deliverables for Matterport. And then similarly, from any point cloud that you get, we can bring it into Recap and use it inside of Recap as a reference as well. So I'm just going to open the Recap file here. Actually, might be behind. Let's see here. There we go. So in Recap, we might bring in files and then create, and I'm going to actually go back here. I just wanted to quickly open a, yeah, and let's see here. There we go. So inside of Recap, we can kind of use that, kind of like the Matterport virtual walkthrough. So when I'm BIM modeling or developing a a building information model. I might have this open on another screen. I can see how it looks in the point cloud. This is actually the point cloud view, but then every one of the scan locations also has what the three-dimensional pictures look like. So for instance, I can see every scan that I've taken and navigate through the point cloud. So you don't have to go back to site every time you say, oh, well, you know, where were those sprinkler heads? Where was that slab? What was going on in this area? Okay. So that's a way that we can use the point clouds as a reference, and we can use that in any way. So if I use it a lot for scan to BIM and saying, oh, well, I'm modeling my my building, I want to look at what's going on in this area, I have it open on another monitor, and I can use it as a visual confirmation of how the modeling's going. Okay, so so what else can we use it for? Scan to BIM. That's one of the big things we do at SolidCAD, and I'm involved in this quite a bit. So I'll go out to site and you know, take one of the scanners, and depending on what the project is, I'll decide whether I could maybe use Matterport. If it's an interior job with a lot of small rooms, I can use Matterport. For instance, I did a residential project that was 9,000 square feet. I can take the Matterport in there, and in half a day, I can do all the scanning and you know, come up with a point cloud that then I can bring into Revit. If I need to go and do an industrial building or an exterior that, you know, is quite high or really large spaces, I may want to take the Faro. You know, there's kind of using the right tool for the right job. Okay, so then so we're going to use this when we capture the point cloud data. I'm going to use the point cloud data to then import it into our CAD software and model a building information model from that real world data. So we can, inside of Revit, then we can cut sections through the point cloud, elevations, align the building all elements with a lot of precision. So the point cloud comes in, I can cut through it, and I'll show you a little bit more of that when we get in, and I'll show you some examples of what we've done in the past. So here's a little snippet of kind of the workflow. So we take the registered scan data out of Recap, and what we can do too is we can also edit those points and point clouds inside of Recap. We can adjust the coordinates so that they come in the right location. We can get rid of any extraneous points or point cloud information. There's no point in bringing in any more information than what we need. We can then export. Actually, it's just really a save. And that is one important thing, that Autodesk Revit, the only point cloud that you insert into or link into Revit is an RCP file or an RCS file. So that's a recap file. So even with Matterport giving us an XYZ file or just a different file format of a point cloud, we would open that up in Recap and then save it out so that we can then bring it into Revit and create the geometry from that. So then we create the point cloud, we've already created the point cloud from the raw data, whether it's Matterport, where we download the XYZ file, register it, and export from Recap as an RCP or an RCS file, or just transfer the files from the laser scanner to our hard drive and use Recap to make the RCS file. Then we bring that data into our Revit model using, and one thing I want to touch on as well is inside of Recap, we can bring in the individual scan files and we have a choice of automatic registration versus manual registration. Basically, all that really means is we take individual scans, they save them as individual files, and then when we put them together inside a recap, we decide whether we want to have the software do it automatically, in which case we may have wanted to use spheres or targets when we do the scan. And you may have seen that in literature, or maybe when people are actually scanning, they're putting up targets or using globes, or use a manual registration, which means I basically have one scan on half my screen, the other scan on the other half of my screen, and recap will try and make a match. And if it can't, I put a couple targets on one side, a couple targets on the other side in the same spot, and then that's how we register that point cloud to get one complete point cloud. So once we have that complete point cloud, then we link into Autodesk Revit. We use the point cloud link as a reference to create our building information model. We can also use Autodesk Recap Pro to reference the RCP file, as I mentioned before, or that Matterport walkthrough, so that when we're building our building information model, we have that as a reference. And then I'll show you a quick demo of kind of the workflow. So we're going to assume we have already been to site and scanned all of the data that we need. And I'm just going to open up Recap. And I'm going to go back to, I'll just get out of this. Actually, maybe I'll close it down. And I made a little test here with just a few raw scans. So if we look at the raw scans folder, I have about 11 raw scans here. So these would represent individual scans. So this would be the Faro or the Leica when they create individual scans. And then I'm going to import these raw scans into Recap and create this RCP file. When I open this RCP file, you can see that here's the individual scans, and I'm going to resume a registration. And this is the manual registration. So this is where I would look around. So I have my registered scans on one side and my unregistered scans on the other. So I'm adding the scans from the left, or sorry, from the right to the left. So I'm going to find a scan that's close to this one in proximity. And here it is. So we've found a match. So if I'm happy with the way that looks, and it tells me, you know, what the new scan is versus the other scans, if I'm happy with that, I can just click on Merge Scan. If I'm not happy with that, if it says it's not lining up properly, what I can do is I can just find common elements, and I might want to just paste these targets or little points in these areas, and I'll find common elements in both scans. Let's do this calendar. And let's see if I can find another one here that's common. It doesn't really matter. Let's see. Here, I'll go on the floor here beside the fridge. And now it'll say that they found a match, and now we can merge the scans. So essentially what that does is then pulls my scan over, puts it in here, and that's how we work through our creation of the point cloud. Okay, so I'm gonna not really worry about this, because what happens is now this one's gonna merge, and then what happens is I have to combine them all. So that takes a little bit of time. So what I'll do is I'll just go out And I'll open up Revit, and I'll show you one of the files that we are one of our scan to BIM projects. So this project is actually the Royal Canadian Yacht Club, and it was scanned. It took us about there was 2 of us. We probably could have done it with 1 person, but it took us about 5 days to scan. It was 65,000 square feet, 4 or 5 floors. It was a bit of a there's lots of mezzanine levels. I'm just opening up in Revit here. Okay, here we go. So the deliverable was floor plans, reflected ceiling plans of the whole building, which we gave them. And I just want to kind of show you some of the 3Ds. So here's a 3D view with the associated point cloud. So essentially what happens here is we put the point cloud in with no geometry, and then we just use the point cloud as a reference to create the geometry. So the difference between the Revit geometry and then the Revit geometry with the point cloud. And we used the Faro scanner in this, extremely accurate. And then we were able to create the 3-dimensional BIM model, which then the deliverable was every floor plan, every ceiling plan, all the lighting, and just from starting with the scan, the laser scan. And so I don't know, like, you know, had underground parking garage, spiral staircases. I don't know how you would go in there with any accuracy and say, oh, well, yeah, I can do this with a clipboard and a tape measure and a laser pointer. But yeah, that's generally the workflow that we use to do scan to BIM. So what I'm going to do is I'm going to pass it over. I do have a couple other case studies that we've done, and maybe I'll just quickly go through them here. We did the Toronto Island Yacht Club, and then also there's a really interesting project here, an observatory. So, you know, if someone called you up and said, hey, I want you to build us a Revit model of this observatory, but, you know, just go in there with a laser measure and a tape measure. You know, so there are obviously some really sweet spots for how scan data can really help you with this type of you know, in this, I guess, type of project. So I'm going to pass it over now to Kisan, and he's going to talk about how to automatically take the point cloud and then automatically generate geometry from that. So here you go, Kisan.
Hi, everyone. My name is Kisan. I'm from Montreal, Quebec. And are you seeing my screen actually?
Yeah, we can see the Kisan. It looks good.
Okay. So actually, I will present a small presentation, and I will explain how to use actually the point cloud inside of Revit. So actually, we have 2 choices. If we're using a point cloud inside of Revit, you need to manually draw above those points in Revit. But now I will show you how to use different tools that will aid you, will help you to modelize automatically those walls, those pipes, and those beams inside of Revit. So those are different tools that will help you modelize automatically those families in Revit. So
Actually, Kisan,
I will,
Kisan,
yeah.
I think we're only seeing your PowerPoint your PowerPoint presentation, unless you haven't changed it yet.
No, it's still on the PowerPoint here. Okay.
Oh, okay. Okay. Yeah.
So actually, I will concentrate on one tools. I will use the Faro as-built tools. I will not do a big PowerPoint presentation here. I will present my Revit file. So Peter, do you see my Revit file? Public?
Yeah, that's good.
Okay,
Yeah,
so
that's great.
you see here, the manual way here, this is a small house. And you see here a point cloud inside of Revit. So actually, if you're doing it manually, you will need to go on the walls and create walls and draw above them. So at first you need to measure what's the width of the wall and draw above it. So I will show you here. I will use a third party that's called As-Built Faro, and I will prepare my point cloud here. It will take about a minute here. I will start and I will ask the software to find for me all the walls automatically, and I will work on it. So it will take about a minute, and you see here how clear the image will be used here to help me build those walls directly in Revit. Almost finished. And I will insert that picture right inside of my Revit file. So actually it is converting all the points that I have here to lines that will be recognized inside of my Revit. So here you will see I will use the tool to recognize all the walls automatically for me, and I will use different tools to put windows and doors right inside of a project. It should not be very long, less than half a minute, and everything will be okay. So this is it. Everything is live, and I'm working on a laptop here. Okay. So you see it's finished. I will insert this picture inside of my Revit file. You see how it wasn't very clean inside of Revit if we're working right inside of the point cloud. It will create a new view for me here. Not very long. What I will do, actually, I will show when I will just wait, finish, but I will use a tool that will do something like that. So I'm showing you this was the wall at the beginning, and I will have those walls, those straight lines that will help me to draw and to be able to find by itself the thickness of the wall. I'm go back in here and Revit. You see here, you see the entire wall. So here I will use a tool that's called fit wall, and I will ask for it to find the thickness of the wall automatically for me. If I start fitting walls, I will just need to click inside of those lines, and you see it was able to find automatically for me the thickness of the wall, and it will ask me to insert it here. So I will insert that type of wall here. So by doing that, you will see it create for me automatically a new wall. And I will go and ask them to create new walls for me. So here you see here, we have a different wall that have a different thickness here. And we have a difference of 5 millimeters. With those tools, you can ask to create a new type here. So by doing that, we will have a new type of wall inside our Revit. I will create another one here for you. You see this small wall. Just by clicking on it, it will be able to find the wall and create a new one for me. So once everything is created, I will use, you see here, actually my walls are not closed. So you have two choices here. You can close them manually, or you use the other tool that we call here align the walls automatically for me. So I'll be able here to ask those walls to be closed automatically based on some calculation. I'm selecting my walls and I'm choosing my parameters here. So you see here, actually my walls are not closing and some here are not respecting my minimum tolerance here. By changing those parameters, I can ask the computer to close everything, and if it's below 5 degrees of angle here, it will adjust automatically for me. So it said that actually those are underneath 5 degrees. We have an error here, and I will ask the computer to close the wall for me by changing those parameters here. By updating everything here, you see that all wall was created automatically for me. After, I will show you now how to create inside of that house the doors and the windows for it. Okay, I'm actually in my 3D view. I will open my section box here. So I will concentrate my presentation here on that part of the house. You see here, actually, I have a window and I have a door. I will create automatically doors inside of it with Revit families. Just change the transparency here of my, here, and I'm able to see the windows here that I need to create. I will use help of my tools here, and I will ask here to create a window for me, and it will create a new type of windows for me automatically. I just select here the 2 points that I need here. So just by clicking on it here, I'm going in the project. I'm just clicking on it. It will able by doing that, you see it has create automatically for me. I'll show you here. The window in my model. So actually, if you were doing that manually, to be able to do that, you will need to take all the measure and insert the right size windows to be able to do that. Actually, if you're working inside of the tools, by clicking on the edge like that, you will be automatically able to create the windows for you. So actually, I will do something similar for the doors. I will ask to create here, but I will create based on 4 dimension here. So actually what I will do first, I will just put the transparency here so you're able to see what I'm doing. I will create here some doors. And I just click here and say, look, those are the edge of my doors. One here, another edge here. And I have an edge here. And I have the other edge here. And by clicking on it, you see, I create a door automatically for you based on the right measurement. Actually, the only thing I have here is the door is not the right side, open. The door is not open in the right side. I just need here to go and click on it and just to switch the door here. So actually, you see, I just create automatically those families inside of my project. I will be able to do the same thing here inside of a structural model here. I have a structural model with a point cloud inside of it. And you see here, I have already discovered some beams. If I'm turning off the point cloud, you will see that I have some of them that was created. I will just turn them on. And I will be based on those tools. I will ask the same thing here with the as-built tool to be able to fit for me those structural elements. So I'll just click here and ask them. Yeah.
Okay, we're just going a little bit over our time now, but I'm just going to let you keep doing the demo in the background. And I'm just going to open it up here if anyone has any particular questions that we can answer for you. Please post the questions in the question dialog box. Yep. If you want to keep going, Kisan, it's good, and I'll just monitor the questions for you. So, Kisan, do you want to just briefly just describe how you use the internal library to automatically generate the point geometry to the point cloud?
For the walls or for the
structural element there?
Okay, so inside here, when you ask the library here, see, by clicking on those 2 points, it will create automatically a section for you. So by creating that section, I will just do a section here. Just detect the type. I will say, look, between those lines here, it will be automatically be able to create and find myself. Oops, something here. It will automatically detect the size. It will detect the size and it will ask me here, does that shape match the size of the member? So here, if you see here, and I will show it in the PowerPoint here slide. When I do the section here, you see when I do the section here, it will ask me here, does that section equal a fit here based on my library? And if I say it is a fit, it will create automatically for me the member or the beams that I need here. So actually, it's only recognize all the, you see here the shape that you are able to recognize. They recognize the shape it based on the point cloud and the library that you have. Well, the tech is the question. Was the answer all right for the client? So you see you are able to move, and I are able here to remove some points here. And I will ask the computer to recalculate and it find a match here. And you see here, you have your library. And if you say that it's a match, it will automatically create the new beams inside of your project. Dan, are you still there?
Yep, I am. So I think we're just going to have to wrap up the presentation here. Again, this was the purpose of this presentation for everyone was an introductory kind of lesson to point clouds and different point cloud technologies that we provide to clients. One of the questions was, will Keyson's PowerPoint be available? We will post this to our YouTube channel, and yes, this PowerPoint presentation, this GoToWebinar, will be available for viewing later on. If there's any additional questions, please just post them at the bottom here. We're just going to kind of wrap up this presentation. We'll stay online for the next five minutes or so. So please feel free to ask away. Otherwise, thank you again for joining us today, and stay safe and enjoy the rest of your day. Thank you. So we're seeing a lot of people already leave. So we're going to close down this webinar. Again, we'll post this through our YouTube channel. And if you have any questions, please don't hesitate to get in contact with SolidCAD. Thank you again. Have a great day.